My name is John Peach, and I'm a data scientist on the Oracle Cloud Infrastructure Data Science Service. In this module, you will learn about why it is important to use the OCI Vault service to store your secrets. You will also be introduced to key concepts such as the different types of keys, key rotation, and storing your secrets in the vault and not in your code. Let us start by discussing what is the OCI Vault and why it is important to you as a data scientist. The data science workflow often requires you to interact with other services, to connect to important data, to store and retrieve artifacts, import and export data, and much more. Interacting with some of these services in OCI requires the use of credentials. For best security, those credentials should not be stored locally or in code, as this is a common way that they are leaked. Therefore, storing credentials requires a service dedicated to that purpose. This service is OCI Vault. The OCI Vault can help data science users to store credentials to databases, secure sites, and other OCI services, so that they can be retrieved at the right time instead of being stored insecurely in code or configuration files. The OCI Vault is an Oracle managed service that allows you to centrally manage your encryption keys and secret credentials. It currently supports 3 encryption algorithms: AES, RSA, and ECDSA. In addition to leveraging the encryption of password credentials to use with your external application, the Vault service integrates with the OCI SDK, command line interface, and API clients. The AES SDK has many integration points between the data science service and the OCI services. This makes it easy to store your credentials in the Vault and connect to the resources that you need to do your data science work. Further, the Vault has integrations to several OCI services under the covers. The main elements include the vaults themselves, keys, and secrets. I'll be covering each of these as we progress further in our training. Essentially, the Vault service removes the need for you to have the storage of these encryption keys and secrets in configuration files or in code. As a best practice, DevOps engineers and data scientists should use the Vault to help improve their overall security position for their applications and services that they deploy. To use the Vault service, you start off by creating one or more vaults. Each Vault service as a logical container where you can leverage the service to create a durable storage for your keys and secrets. When creating a vault, you choose one of 2 types. The first one is called the Virtual Private Vault, which is essentially a dedicated isolation partition in a hardware security module. This option allows you to store up to 1,000 key versions, and you have better isolation, of course, because it's dedicated to you. Another advantage is that you can back up the vault and the keys you have created to an OCI object storage bucket, which supports disaster recovery scenarios and cross-region replication requirements. Default option is to provision the vault in a shared partition. While it is still secure, you share the hardware security module partition with other Oracle customers. As such, you don't get some of the advanced features. For example, you can't back up to an object storage. However, it has a lower cost because you only get charged for the actual number of keys and key versions and secrets that are being stored. So now, what are keys? These are logical entities which are used to represent one or more key versions of cryptographic material. A key's cryptographic material is generated for a specific encryption algorithm. Some of the most secure encryption algorithms are AES, RSA, and ECDSA, and these are all supported by OCI. The encryption technology allows you to use the keys to encrypt or digitally sign your data. The different technologies use various techniques for encryption and decryption. For example, AES uses symmetric keys. That is, there are 2 keys and both of them can encrypt and decrypt the data. RSA and ECDSA use acyclic keys for encryption and decryption. In this case, one key is used to encrypt and the other key is used to decrypt. In the Vault service, conceptually there are three types of keys: a master encryption key, a data encryption key, and wrapping keys. Let's take a closer look at each one of them. To better understand, master encryption keys are the keys that you actually create or import into your vault. You select the encryption algorithm and the key shape, either the number of bits for AES and RSA, or the elliptic curve ID for ECDSA. In addition, there is the concept of data encryption keys, which are generated by using a master encryption key. Data encryption keys themselves are encrypted dynamically with the master key. This is known as envelope encryption. This way your data can use a variety of encryption keys, and those keys can be rotated. If a data encryption key is compromised, only the data using that key is at risk. This reduces the blast radius, as there is generally many data encryption keys. You see, OCI services such as block or file storage either use Oracle managed keys, or you can specify a custom master key from your vault for specific use cases. For example, one or more object storage buckets or a specific block volume can use a particular data encryption key. These master keys are used to encrypt data encryption keys, and the data encryption keys are used to encrypt the data. Finally, let's talk about rotating these master keys. As I mentioned earlier, each key is automatically assigned a key version when you create a key for the first time. When you rotate a key, a new key version is automatically generated, or you can choose to import another key. As a best practice, periodically rotating a master encryption key will limit the amount of data that is encrypted or assigned by one particular version of the key. This significantly reduces the data security risk if each key is compromised. Now you might be wondering, if we rotate a key, how does the Vault service figure out how to handle decryption? For example, if encryption was done with key version 1, but now we're using key version 2, well, behind the scenes, the Vault leverages the Oracle Cloud Identifier, or OCID, of the older version that is needed. While older versions can't be used to encrypt anymore, fortunately they still can be used to decrypt the data, which is encrypted earlier with a previous version. The OCI Vault has three common components: the keys, FIPS 140-2 Level 3 Certified Hardware Security Module, and the secrets. We have talked already about the key and the hardware security module. These two components are used to secure your secrets. Until now, we have not really discussed the third important element, secrets. Secrets are credentials such as passwords or tokens, or other confidential data that you need to use to access Oracle Cloud Infrastructure services, or perhaps external applications or systems. Storing secrets in the Vault provides greater security than you might achieve storing them elsewhere, such as in code or configuration files. As you can retrieve secrets from the Vault service, you need them to access the resources in other services. Storing them in the Vault also makes your code more robust. As the password or other credentials change, you just need to update them in the Vault, and your code will automatically be updated. The idea is to have the OCID of the secret stored locally or in your notebook session. Then when the code needs to access the resource, it can connect to the Vault, obtain the credentials that it needs, and then throws them away. If someone else accesses your notebook or other data science product, they will need permission to access the secret to access the same resource. It is much easier to control access to the secret than it is to control access to the notebook, as notebooks are often meant to be shared. You can create secrets using the OCI console UI or programmatically in code or scripts using the OCI SDK, CLI, or REST API. In addition, each secret is automatically assigned a version. So when you rotate a secret, you provide a new secret contents to the Vault service to generate a new secret version. Periodically rotating the secrets reduces the impact in cases a secret is exposed. The secret's unique identifier, Oracle Assigned Identifier, OCID as it's sometimes called, remains the same across rotations, allowing the Vault service to rotate your secret contents to meet any rules or compliance requirements you might have, while finally, program access remains the same. Let's wrap up. In this module, you have learned that storing your secrets in the OCI Vault is important. We have discussed what the OCI Vault service is. We have covered the types of vaults and types of keys. The importance of key versions and rotations were discussed. And most importantly, we have talked about storing your credentials or secrets in the Vault and not code. Thank you very much. Hello, my name is John Peach and I'm a data scientist on the Oracle Cloud Infrastructure Data Science Service. In this module, you will learn about the different ways to manage your encryption with Oracle and customer managed keys, how to use the OCI SDK to store and retrieve secrets from the Vault. You will learn about some specialized classes in the ADS SDK that are designed to integrate with the Vault. They are designed for the data scientist and the data scientist workflows. They make it really simple to access secured resources that data scientists use all the time. OCI uses encryption in many places in the service. When working with the